Hello, welcome to Point On Studio. My name is Jungwoo Park. Today I'm going to talk about another series of architectural model versus structural model in BIM workflow. Um, when you work with a structural engineer, generally speaking, the structural engineer, they will develop their own structural model because of the reinforcement detailing, and also the analytical model. It's easier for them to organize detached structural model rather than using architectural model, because architectural model maybe is too detailed with different slab profiles or openings, and which not necessary for structural engineers to use it at some point. So if there's jumping slab, they also simplify for analytical model. That's why it's usually it's detached. But many case architectural model also contains structural model, especially for concrete structure, and it is dangerous for structural engineers to use architect's model to work together within the same model. I don't think it's a good idea because of the ownership of model and also roles and responsibility. You don't know if this element is changed or amended by architects or structural engineer unless they really communicate well. Then that way maybe it could be efficient. But when it comes to reinforcement detailing in 3D elements, when everything is one in architectural model, then the performance of model is very slow. So that's the reason why, generally speaking, architect model is separate with structural model. But anyhow, architect usually develop the concept drawing and model in early stage and distribute this model to structural engineer and MEP engineer. Before MEP engineer, generally we share or distribute to structural engineer to discuss about structural concept. And in many cases, there is a slight difference between structural model and architectural model. Some point it looks nothing much, but when we ignore this fact and when project is developed for the later phase, it causes huge problem in terms of cost estimation for quantity takeoff and also the element volume calculation. Not only for that, when you export IFC for openBIM workflow, these categories are very important. I mean, IFC entity and the enumeration is very important. But if both architectural model and structural model has slight difference, so the later phase, the quantity estimators, they may get confused which model it should be used for their solve. So today I'm going to shortly talk about this difference, and let's go ahead. So first example, when we have to be careful about architectural model and structural model, in this example, in some case, architect model, obviously the slab with the slab and the column, some case it's a little bit of confusion between column and wall. I think it depends on norms, how your national standard define. Generally, when you divide this length by the thickness, and if it's the result is bigger than 4 units, then that case you have to use the wall elements. But this sort of regulation is defined by your national standard. But both way is correct. You can build it as a column and you can model as a wall. And also, again, in this case, the reinforcement, there will be nothing different. But most of case, structural engineers for this sort of case, they use column to, use it for the structural analytical model, but some point is also used as a wall. So this really, again, the formula length divided by thickness, and that result of depending on what your national code, and that's maybe architects model it as a wall there or column, or the other way around by structural engineer. And this point you have to always discuss well and communicate well with structural engineer, so you can sort of later phase you can unify them, and you can give the one single source of truth to the other discipline. Let's move on to next example here. As you can see, we have here simple wall and we have opening. That's typical architectural model when it comes to the concrete structure. And structural engineers, sometimes they model not instead just wall, but they put two columns and put the beam bottom and up, so that they can calculate more with more safety factors in their FEA software. But if this happens, let's generally architects, we don't model in that way. We model just simply wall and then that's done. But when structural engineer model in that way, you have to communicate each other, so that later phase when quantity estimators or information manager, when they deal with the other information, you have to give them direction. Or maybe you can use structural engineering model only for the calculation or reinforcement, but actual coordination model should be in architectural from the architectural model. You have to define this rule. But generally, this on the right hand side, this modeling happens when you have, I'm drawing in elevation. Let's say you have multi-story building, and you might have the openings, various openings in your building facade, different size and maybe different position. And in that case, structural engineer, because of there are a lot of openings, so structural engineer prefer to model on the right hand side here. So they put the beam up and down, and the column should be here. You see, in this way they model in exactly like on the right hand side. So in FEA software they can get more precise calculation. Correct me if I'm wrong. So you can always leave the comments down below. If you are structural engineer, please at this point correct me if I'm wrong. But again, the important point here is that the key to success your BIM workflow is again communication especially between architect and structural engineer for those points. Let's move on to another example. Anyway, these both way is not wrong. They are both correct. It's a matter of how you communicate with structural engineer. The next example here, what we are looking, it's also beam and column connections, and generally speaking, on the left hand side is really correct modeling. But many structural office, they also model column to the up top of the beam, and they calculate this sort of analytical model in their FEA calculation software, because it will give you a little bit better result. And but for the reinforcement detailing, of course, this is when the left hand side is more correct. So there will be, the structural model you may appear in this sort of modeling, but architectural model we may model in that way. And in this case, when you link, anyway, most of case reinforcement detailing model is adopted by general case, and we link that reinforcement model into architectural model. So I don't see any big problem in this two model difference, but it's always nice to coordinate this difference between architectural model and structural model, so you can avoid this confusion, right? Let's move on to another case here. This is very, I see a lot of common mistake from both architectural model or structural model. We have here Z-type beam, which dealing with this sort of jumping slab. And usually architect or structural engineer, they model in between here with slab, and architect may model with wall, or structural engineer may with beam, or the other way around. This both solution is correct, but sometimes when you have longer span, here in this case longer span, and your structural beam in this case has to be longer, then your analytical model, you'll have the one node point and another node point, and we have analytical line in between. In this case, if the span is wrong here, some point there is no connection between, you know, your analytical surface of the floor. So the result, even though you giving coupling connection between this node point to the slab below, this in the middle here, long span middle way, this result may not correct. So in this case, structural engineer also suggests to model with a wall. In that way, it's more correct. But you know, you always can expect to have two different methods in your BIM workflow, and when you get difference between architectural model and structural model, then that's the point where we have to communicate each other. So the both solution is correct, but when somebody model this downstand beam or like upstand beam with slab, then you know this is absolutely not correct. Structurally, analytically, and also reinforcement detailing way, these are not correct. All right. So, and also we should always model as constructed, as built. So how we construct in reality, that makes more sense. But on the right hand side, if you see the geometry, sometimes we get this sort of geometry. So floor is cut. Basically here, this is also correct, because between floor and beam in this case, they are kind of, this area here is kind of same zone, but you know, this modeling is it's generally not suggested. And you can, or wall, bottom of wall above the top of slab here, and the other here is finished, but this is also not accurate model. Or the other, top of the wall is below bottom of the slab, above the jumping slab there, and in this way is also incorrect. And of course it depends also on the jumping slab, the difference, the height difference. If it's more than, you know, 1.5 meter, we should consider that as another building story, especially when the floor area is bigger than 30 square meter. Then you know, it's considering to really another building story. So in that case, you have to think about what method is the best to get your quantity takeoff as well as structural analysis with reinforcement. So this point we have to well discuss. And here we have downstand beam below the slab. In this case, this framing doesn't, you know, there's no element below, so it's kind of, you know, always tricky. But many case, in reality, this area here, the overlapping area between floor and beam, it's actually same area. So you know, that's why a lot of case the structural engineer may model beam here and then make two different floor like that. Of course, it's not suggested in that way because of the, you know, calculation. Because in this case, what you will get this sort of analytical model with node points, and then here we have another analytical line, which is they are detached. So you can create, of course, the link with a coupling, but you know, this is not good solution. So it's more suggested in that way. We use slab and beam below as a downstand beam, but this geometry, you know, let's say that's the common area, but the beam is more or less bottom of the slab. Sometimes architects make mistake with the wall tool there, and this is incorrect because wall is not supported by anything, so it will be always giving additional error in analytical model. And or sometimes they draw here slab, two different slab, but this is completely incorrect. So please just keep in mind that this sort of this sort of two slab modeling for downstand beam is we must avoid this sort of mistake. I think that's it. For me, this main area I see from many models, we have always this sort of important point to discuss with structural engineer. And as an architect, our main role is like really coordination in BIM workflow. I mean, everyone has to coordinate anyway, but the architect has to coordinate all kind of different discipline into architectural model and have to assign what you know, what mistake we have, because this could be directly affect your design. And I hope this simple 5 use cases are helpful for you. And if you like the video, please click on like and subscribe my channel. That way you can support my channel to continue my hobby. I'm trying to share this knowledge as much as I can these days, because I think I have some sort of experience now that I can share with you. But please correct me if there's something wrong or something incorrect, especially if structural engineer who watch this video. If I'm wrong, please correct me, because I'm not the structural engineer. Alright, thank you. Thanks for watching it. Bye bye.